So welcome back, students. Now we are entering the second lecture of quantum mechanics, and after uh, the matter wave concept and why the quantum mechanics has been introduced and why it is useful, now we come to the point of this concept of wave function. This is very essential to got to know the Schrodinger equation and their application part also. So we start with this. So now this formula we have derived, we have gone through this formula lambda equal to h upon mv or h upon v. This is the formula for the wavelength of a matter wave. So this lambda is h upon mv, then m is the mass of particle, v is the velocity of the moving particle. Now the concept is that now we calculate the phase velocity. This is very simple. The phase velocity is the omega by k. This is from the characteristics what we have gone through or we know earlier from our previous knowledge of wave mechanics or the theory. So omega is 2 pi nu, k we know 2 pi by lambda. So ultimately my phase velocity will be nu lambda. Since we know E equal to h nu and this is equal to mc square that we have done earlier. So this nu p, the phase velocity, we can write here is mc square. This nu will be mc square by h. So I am writing nu is mc square by h, and here my lambda is h upon m. So what we can do, what I am doing, this is the formula Vp equal to nu lambda. So I am putting the value of lambda from here. I am putting the nu from here. So ultimately this nu p will give me c square by v. So what is the meaning of this? This phase velocity is c square by v. And since we know all the particles, all the matter can attain the maximum value which will be equal to c. Now, since already we know that V should always, V is day-to-day life, V is always less than C. So you can get to know that C multiplied by C divided by V. This V is less than C, always. So what will happen that I will left here C and then multiply by some of the quantity which is more than 1 point something. Why 1 point? Because C by V, this V will not be equal to C. So my C by V here will lead me 1 point something, and that 1 point something will multiply with C, ultimately give me the Vp which is more than C. Is it okay? It means that my matter wave can be greater than the velocity of light. And this is very special. This is very special because it means since our particle is not moving with a velocity which is more than c, but the phase velocity is moving which is more than c. And it means a wave is not associated with moving particle. This is not true. It means simple wave is not the case to represent a matter wave with a particle. What we are doing that now we know that any particle, any matter in the universe contain the wave. If I am going to derive the phase velocity of that wave, suppose I'm targeting an electron. Electron should have a wave, as we know from de Broglie hypothesis. So what will happen? The wave should have this kind of velocity, but this velocity is not good because from this velocity the particle will stay behind and its wave will keep moving with the speed which is more than c, and that is not practically. So what happened? Then we suggest the group velocity also. So this group velocity means it's not one wave, it is the combination of a variety of the wave. And if suppose we are taking this velocity of matter wave as a combination of the variety of the wave, then the velocity will call the group velocity. So that was single velocity, that is the group velocity, which is d omega by dk. The formula. We have the formula now, d E equal to h cross omega, p equal to h cross k. Now what I am doing, I am just changing the differentiation, d omega by de multiply by d and divided by d. So de by dp, then multiply by dp and dk. So it's very simple. Omega is now in form of e, k is now in form of p, and ultimately dp by de here. So I am changing this differentiation. So omega is e multiply by e. E is with the differentiation of with respect to p and multiply with p. So this term we can do that. So ultimately this d omega by de we can calculate from here, which will be, if you multiply, you differentiate here. So de will be h cross d omega. So you will get d omega by de, which will be 1 upon h cross. Similarly, you can get it dp by dk from here. dp by dk would be h cross. So these two quantity, the first one and this one will lead to 1 upon h cross and h cross. So this will be cancelled out. So ultimately my Vg will be dE by dP. So d omega by dk has been now changed in dE by dP. What I can do, this dP, so dP is now d by dP. I know E is p square by 2m. So from here, what we can do, that I can do this p square by 2m. I differentiate this equation with respect to p. I will get p by m. P we know, mass into v. So mass into v will give you mass cancel and v. It means now if I consider a group velocity, then it will be exactly equal to v. What was v? V was the velocity of the particle by which it is moving. So what we got from here, that I want to construct the wave nature of a particle or a matter, and if I want to know the wave nature of a particle, so what will happen, this phenomena of Vp will not be validated, because this, from this formula, the wave is not associated with the particle itself. But yes, definitely this Vg, if we are targeting Vg, then it is the wave which is moving with the same velocity as the particle is moving. Hence, what we conclude from here, if I want to construct a wave, it should not be a single wave. It should be the group of wave to target this kind of matter wave. And this group of waves or the superposition of all the waves is known as wave function. Hence, I should say the wave function is the wave which represent the particle's wave nature. So this Vg comes out to be V, and hence look there. So I am representing now my particle or the wave which is associated with the particle. So it's not a single wave, it will be superposition. So the group wave of the wave now is in this way. So this is my wave function. Suppose particle exists here. So the particle is here, but its wave is associated in this way. Now this kind of phenomena, this kind of nature of wave cannot be a single wave. It means this is happening because there are variety of waves, there are superposition of waves, and which will give you this kind of pattern for the wave function, and this will known as wave packet also. So the meaning is very simple, that we are having a particle. We know that due to matter wave, it should contain a wave associated with it. It should not be a single wave. It should be the group of wave, and that group of wave will result you this kind of envelope. This envelope will provide you. This envelope will provide you the situation that this envelope contain maximum where the particle exists. And once you move towards this side or towards this side, you can say the wave nature is diminishing. It means definitely the wave should be there where the particle is there. So I think I can say the probability of the finding the particle here is maximum. And if you are moving away from the particle, then the probability or the wave function will be diminishing. It means there is no particle beyond here or beyond here, and that is very much truthful or very much considerable. So how to represent this wave? That is the phenomena. How to mathematically, how can represent this wave packet or the group of the wave, and that is what we integrate. We can integrate, matlab we are adding, and these all can be represented by exponential of iota h cross px minus et. This we know already, that this kind of pattern we usually show in our interference or diffraction whenever we have studied y equal to a sine omega t minus kx. So this is similar to that, sine omega t minus ks. Now we are representing in form of exponential. So this psi, that this is what we have taken this sine or cos. We can take cos also, and the combination of sine and cos will give you the exponential. So psi xt is equal to a e to the power iota kx minus omega t. Now this k you can change in form of p upon h cross. This omega you can change in form of e upon h cross, and hence we can write this I upon h cross px minus et. So this particular equation is representing the wave function. So psi is the wave function, psi is the group of wave, psi is that in this form in which you can represent the wave nature of a particle or the matter. Now moving further. What is the physical interpretation of wave function? What is its property and boundary condition? So we have gone through it that lambda is this mv. We have also proved it also that from this equation you can calculate that vp is equal to c square by v. Phase velocity of wave associated with particle is much higher. So and also we have taken that vg. If you take vg, then vg equal to v will give you. So this is what the wave function. So what is wave function? So it's very simple. It's varying quantity characteristic. The matter wave is denoted by psi x, phi, z, three-dimensional. At a point, that is the quantity whose variation makes up the matter wave is known as a wave function. And we represent this wave function in this way. The psi x equal to a exponential minus iota omega t minus x by this iota, you know, root of minus 1, this imaginary quantity. So we can represent psi in variety of form. As I told you, psi is equal to a exponential minus iota h cross et minus px. So you can represent it in this way also. Now we're moving further, physical significance of wave function. So the physical significance means you know the psi. Now you can represent psi as form of complex quantity, real number, imaginary number, you know. So a plus iota b. Then psi star you can take a minus iota b. If you multiply the psi and psi star, then you will get a square plus b square. I hope you know this all algebra, which is the algebra from the real quantity, imaginary quantity, or complex quantity. So p is equal to a square plus b square. This p is actually known as the probability amplitude. So this is probability density. So this probability density is P, which is given by psi multiplied with the complex conjugate of psi. So psi multiplied by psi square is the P. If you integrate this with respect to volume elements, P dV. So I'm multiplying this P with dV. dV means the whole volume element. Then by this quantity, psi square dV is known as the probability to find the particle in a defined space, and which is directly proportional to the integral over the space. So what is the mean? This, suppose my particle is moving in one dimension, then I multiply p with dx. If my particle is moving in three dimension, then I multiply this quantity p with dv. So what I'll do, if suppose my particle in one dimension, I have this psi xt square, there is only x, no y, no z, multiply by dx, I integrate this quantity from minus infinity plus infinity, and this will give me the probability to finding the particle for all space in one dimension. However, if you multiply with dv and you take this psi for one x, y, z, and t, all dimensions, then if I integrate it, this will give me the probability to find a particle in all 3D space. So this is one of the quality of the wave function, that my wave function is having this kind of physical significance, that it directly give me the probability of finding the particle, and it should be, because this wave is associated with the particle only. So wherever the particle is maximum, my wave function will be maximum. So the probability to find a particle is represented by these two equations, which are known as the probability of finding the amplitude. Next, some of the characteristics and Schrodinger equation I will take in the next lecture.